Okay, for this last Institute help on Newton's laws, I put 9 and 10 together. They don't really go together, but they both use Newton's second law, which is the main thing we're using, and they're not using kinematic equations. Number 10 is kind of nice because it actually uses Newton's third law a little bit. Um, but number 9, to start off with, is kind of going to take into account a free body diagram as well. So when a parachute opens, the air exerts a large drag force on it. This upward force is initially greater than the weight of the skydiver and thus slows him down. Suppose the weight of the skydiver is this, and the drag force is this. What is the magnitude and direction of his acceleration? So for this, we have like an extra piece that they're gonna sneak in here on number 9. They give you the weight of the skydiver. So we're gonna have to use this weight to figure out the mass of the skydiver. Because mass would equal the weight divided by 9.8. So we're gonna have to take that 915 newtons and divide it by 9.8 to get the mass of the skydiver. Then after that, if I kind of think of the free body diagram here, if I imagine the skydiver has his parachute on him, we know that there are going to be two forces acting on him. We have the force of gravity, that's his weight, that's going to be the 915 newtons. Then we have this drag force that's acting on him, and this drag force is going to act in the opposite direction. So it's going to be an upward force, I'll call this F drag, and this is the 1027 newtons. So when I get ready to actually solve this problem, one of the key ideas is we are going to look at the net force on him. So the net force is going to equal his mass times acceleration. Or to find his acceleration, we need the net force over the mass. So we have to calculate the mass from this. This is going to allow us to get the mass. So check, we've got that. Boom. Net force is going to be the difference between these two. Now you can do this one of two ways. You can either take drag minus the force of gravity and think of the force of gravity as being downward, so it's negative, and therefore when you get a positive answer, it means that they're accelerating upward. Or you can do down as positive and up as negative, and when you get a negative answer, you're going to get an upward acceleration still. I personally like to do this as 1027 and think of that as the positive direction, so that's up, and then I like to subtract this 915 because it's in the downward direction, and then divide that by the mass, which we have right there, and that would find my net force. We should get a positive answer to indicate that its direction is upward. So for this direction, I would love you to say upward, or if I can see the work, I should be able to see how you're actually kind of setting it up. That's number 9. So I had an extra little tidbit because you had to use the weight equation. 10 doesn't have that. It really is more of a understanding Newton's third law. For every action, there's an equal opposite reaction. For every force, there's an equal and opposite force. So I have a man, 82 kilograms, and a woman, 48 kilograms. The woman pushes on the man with 45 newtons to the east. Okay? So let's draw the man here. And then we'll just draw the woman over here. Also pushing like that. Okay. So she is pushing on the man with a force of, so this is the woman on the man. That's 45 newtons east. For every action, there should be an equal and opposite reaction. So therefore, the man is going to push on the woman with a force of 45 newtons west. So the force of the man on the woman would be the same magnitude, just opposite direction. Okay? So we're going to use that to solve these. So if we're trying to find the acceleration, direction, and magnitude of the man and the woman, that's how we're going to kind of solve it. So we come up here. So for part A, If we're trying to find the acceleration of the man, then we need the force on the man. So this is of the woman on the man divided by the mass of the man. Okay, so these are all man, man, man. Okay, we know that force, we know that mass. Check, check, we're good. Then over here for part B, we're actually going to take the acceleration of the woman, that would be the force of the man on the woman, divided by the mass of the woman. Again, check, check, solve. Okay? So just reminding you about Newton's third law: for every action, there are equal and opposite reaction. Hope that helps.